Buckle up, everybody, because today we are launching ourselves into a deep dive of our solar system.
Yeah, we're going to hit all the highlights from the sun to the icy outer regions and beyond.
It's pretty mind-blowing when you think about how much we've learned, even in just the last few decades.
Oh, absolutely. Missions like Voyager and Cassini just totally revolutionized our understanding.
Yeah, it feels like every time we send a probe out there, we just get more questions than answers.
Right. But hey, that's what makes it so exciting, right?
Totally. So let's start at the beginning with the big guy, the sun.
The heart of our solar system.
It's crazy to think that it accounts for like 99% of the solar system's mass.
It's true. Everything we see around us, the planets, the moons, the asteroids, all of that makes up less than 1%.
So it's not just a giant light bulb in the sky.
No, it's the gravitational anchor that holds everything together.
But what's actually going on inside the sun? I remember learning about nuclear fusion back in school, but it's kind of hazy now.
Right, so it's not burning like a fire, it's hydrogen atoms fusing to become helium, and that releases an incredible amount of energy.
And that's what powers the sun.
Absolutely. But get this, it can take millions of years for that energy to travel from the sun's core to its surface.
Millions of years.
Yeah.
That's longer than human civilization has even existed.
It really puts things into perspective, doesn't it?
Totally. And once that energy reaches the surface, it travels across space at the speed of light.
Reaching us here on Earth as light and heat, providing the energy for life as we know it.
But the sun's not always so friendly, is it? I mean, we hear about solar flares and coronal mass ejections.
Right, this can be a bit of a double-edged sword.
They cause the auroras, right? Those beautiful light shows in the sky.
They do. But a powerful solar storm can also disrupt satellites, communication systems, even knock out power grids.
So we rely on the sun for life, but we also have to respect its power.
Definitely a healthy balance.
Okay, well, let's move on to our first planetary pit stop, Mercury.
The smallest planet and the closest to the sun?
I always picture it as this kind of cratered, barren world.
That's pretty accurate. It's a place of extremes with scorching hot days and incredibly frigid nights.
Like, how hot are we talking?
Well, during the day, temperatures can soar to over 430 degrees Celsius.
Wow. That's hot enough to melt lead.
But then at night, the temperature plummets to around a naked 180 degrees Celsius.
That's a bigger temperature swing than anywhere on Earth.
Oh, absolutely. And it's all because Mercury has almost no atmosphere to trap heat.
So it's basically just baking in the sun all day and then freezing solid at night.
Pretty much. And to make things even weirder, Mercury has this unusual way of rotating and orbiting the sun.
Yeah, I remember reading about that. Something about the sun appearing to move backwards in the sky.
Exactly. Because of its slow rotation and elliptical orbit, you could actually see the sun rise, stop, and then briefly move backward before continuing its normal path across the sky.
That's just bizarre. It's like Mercury's playing tricks on you.
It's definitely not your typical sunrise.
Okay, so from the extreme temperatures of Mercury, let's move on to our next stop, Venus.
Often called Earth's twin because of their similar size.
But Venus is more like Earth's evil twin, right?
That's a good way to put it. It's a scorching hot, volcanic world with a super dense atmosphere.
So instead of a nice breathable atmosphere like we have on Earth, Venus has this thick blanket of carbon dioxide.
Exactly. And that creates a runaway greenhouse effect, trapping heat like a pressure cooker.
So how hot does it get?
The average surface temperature on Venus is a scorching 464 degrees Celsius, hot enough to melt lead.
And the pressure.
Imagine being 900 meters beneath the ocean's surface. That's the kind of pressure we're talking about.
You'd be crushed like a tin can.
Yeah, not exactly a hospitable place.
Yeah.
And just to add to the weirdness, Venus also rotates in the opposite direction of most planets.
So the sun rises in the west and sets in the east.
Exactly. It's like Venus is doing everything in reverse.
Okay, so after braving the heat of Venus, I'm ready for something a little more familiar, Earth.
Our home planet, the pale blue dot.
It's easy to take Earth for granted, but it really is a special place.
Absolutely. We have liquid water, a stable climate, a protective atmosphere, and all the right ingredients for life to thrive.
And we can't forget about our moon, which plays a big role in stabilizing Earth's tilt and creating those tides we all love.
That's right. The moon's gravitational pull helps keep our planet's wobble in check, which is essential for maintaining our stable seasons.
But let's not forget about our next-door neighbor, Mars, the red planet.
A cold, dry world with a thin atmosphere, but there's evidence it wasn't always that way.
Right. I remember seeing images of those dried-up riverbeds and lake beds hinting at a past where water flowed freely on the surface.
Exactly. And scientists believe Mars once had a thicker atmosphere, too.
So what happened? Where did all the water and atmosphere go?
That's one of the big mysteries we're trying to solve. Some theories suggest that Mars' magnetic field weakened, allowing the solar wind to strip away its atmosphere, which then led to the loss of its surface water.
So it's a cautionary tale about the importance of a strong magnetic field.
Definitely. It's one of the reasons why Earth is so habitable. Our magnetic field acts as a shield, protecting us from the sun's harmful radiation.
And speaking of protection, as we journey out past Mars, we encounter the asteroid belt.
A region between Mars and Jupiter filled with millions of rocky remnants from the early solar system.
Like a cosmic minefield.
In a way, yeah. Most asteroids are harmlessly orbiting the sun, but there are a few that have Earth-crossing orbits, which means they could potentially pose a threat.
That's why we have programs dedicated to tracking those near-Earth asteroids.
Exactly. We want to know what's out there and if anything is heading our way.
Okay, well, I'm glad someone's keeping an eye on those space rocks because we're about to enter the realm of the gas giants, starting with the king itself, Jupiter.
The largest planet in our solar system by far.
It's mind-blowing how big it is. You could fit 1,300 Earths inside Jupiter.
It's true. And it's not just about size. Jupiter is a constantly churning world of colorful bands, raging storms, and a whole entourage of fascinating moons.
Yeah, when I think of Jupiter, I always picture that giant red spot.
It's a great red spot, a massive storm that's been raging for at least 300 years.
300 years. That's older than the United States.
It really puts things into perspective, doesn't it?
Totally. But what's causing that storm to last so long?
It's still a bit of a mystery, but scientists believe it has to do with Jupiter's unique atmospheric conditions. The combination of its fast rotation, internal heat, and the properties of hydrogen and helium at high pressures create these incredibly turbulent conditions.
So it's like a giant cosmic blender just constantly whipping up these storms.
Pretty much. And it's not just the Great Red Spot. Jupiter's atmosphere is full of storms, some of which are even bigger than Earth.
That's just wild.
Yeah.
And then you have those incredible swirling bands of different colors.
Those are caused by different atmospheric gases and compounds,
Yeah.
all being churned up and mixed together by those powerful winds.
And let's not forget about Jupiter's moons. It has a whole bunch of them, right?
Over 70 that we know of. But among those, there are 4 that stand out. The Galilean moons, named after Galileo, who discovered them.
Io, Europa, Ganymede, and Callisto, right? I remember learning about them in school.
And each one is unique and fascinating in its own way. But one in particular has scientists really excited about the possibility of life beyond Earth.
Which one is that?
Europa.
What's so special about Europa?
It's thought to have a vast saltwater ocean beneath its icy surface, possibly containing more water than all the oceans on Earth combined.
An ocean on another world? That's incredible. But how do we know it's there?
We've seen evidence of geysers erupting from Europa's surface, spewing water vapor into space. And based on observations from spacecraft like Galileo and Juno, scientists believe there's a salty ocean hidden beneath that ice shell, possibly heated by tidal forces from Jupiter.
So it's like a giant cosmic slushy with a hidden ocean inside.
That's a fun way to think about it. And what makes it even more exciting is that there might be hydrothermal vents on Europa's ocean floor, similar to the ones on Earth that support entire ecosystems without sunlight.
So there could be alien life swimming around in that dark, hidden ocean.
It's definitely a possibility, and that's why Europa is such a high priority for future exploration.
It's mind-blowing to think that we might find evidence of life on another world right here in our own solar system.
It would be one of the greatest discoveries in human history.
Absolutely. So Jupiter is not only the biggest planet, it's also the guardian of the solar system with its powerful gravity that helps deflect comets and asteroids.
That's right. Jupiter's gravitational pull acts like a giant shield, protecting the inner planets from potential impacts.
So we owe Jupiter a big thank you for keeping us safe.
Definitely. It's a vital part of our solar system's delicate balance.
From the king of planets, let's move on to the beauty queen, Saturn, with its stunning rings.
It's definitely the showstopper of the solar system.
Those rings are just mesmerizing, made up of countless icy particles, ranging in size from tiny grains to huge chunks bigger than houses.
And they're constantly in motion, orbiting Saturn at incredible speeds.
I remember being blown away by the images from the Cassini mission that orbited Saturn for over a decade.
Cassini was an incredible mission. It gave us a whole new understanding of Saturn, its rings, and its many moons.
What were some of the big discoveries that Cassini made?
Well, it revealed the intricate structure of the rings in unprecedented detail. We saw propeller-like structures created by moonlets embedded within the rings, We saw spoke-like features that suggest the presence of tiny, unseen moons shaping the rings. It was like a whole new world opened up to us.
So it's not just a flat disk, it's a dynamic, ever-changing system.
Exactly. And speaking of dynamic, Cassini also captured stunning images of Saturn's atmosphere, revealing powerful storms, swirling jet streams, and even that bizarre hexagonal storm at its north pole.
The Great Hexagon, right. How can a storm be shaped like a hexagon?
It's one of the most puzzling features in our solar system. Scientists believe it's caused by atmospheric waves interacting with the planet's rotation, but the exact mechanism is still being debated. It's like Saturn has its own unique set of rules when it comes to weather.
It's just incredible. And then you have Saturn's moons. Titan is the one that always captures my imagination.
Titan is a truly unique world. It has a dense atmosphere, thicker than Earth's, and it's the only moon in our solar system known to have stable liquids on its surface.
But instead of water, it's liquid methane and ethane, right?
Exactly. Imagine a world where natural gas flows like rivers and lakes.
It's like something out of a science fiction movie.
And Cassini was able to send a probe down to Titan's surface, giving us our first glimpse of this alien landscape.
What did we learn from that probe?
We learned that Titan has mountains, dunes, and even cryovolcanoes, volcanoes that erupt with icy materials instead of molten rock.
Cryovolcanoes, that's amazing.
And the data from that probe is still being analyzed today, revealing new secrets about this fascinating world.
So Titan is a world of methane lakes, cryovolcanoes, and a dense, hazy atmosphere. It's like a whole other Earth, but with a completely different set of ingredients.
Exactly, and it just goes to show how diverse the worlds in our solar system can be.
Okay, so we've explored the rocky inner planets, navigated the asteroid belt, and marveled at the gas giants. Now we're heading into the realm of the ice giants, a region of our solar system that feels almost alien in its coldness and distance.
Next stop, Uranus, a planet tilted on its side, wrapped in a pale blue-green atmosphere, hinting at the secrets hidden within.
Uranus is definitely unique, and its tilt gives it some pretty extreme seasons.
Imagine a world where winter lasts for 21 Earth years, with one pole facing the sun the entire time.
I can't even imagine. What could have caused a planet to tilt over like that?
The leading theory is that early in its history, Uranus collided with a massive object, maybe even another planet, which knocked it off its axis.
Wow, that's one heck of a cosmic fender bender.
It must have been an incredible event, and that tilt gives Uranus some pretty unique characteristics, like its extreme seasons.
And Uranus has rings too, right? I remember seeing those images from Voyager 2.
Yes, it does. They're much fainter and darker than Saturn's rings, but they're there. And Voyager 2 also discovered a bunch of new moons around Uranus, adding to its already fascinating system.
Voyager 2 really was a pioneer, sending back those first glimpses of these distant worlds.
It was a landmark mission, giving us so much new information about the outer solar system.
Okay, well, from the tilted world of Uranus, let's move on to our final stop for this deep dive, Neptune, the 8th planet from the Sun.
The other ice giant, named after the Roman god of the sea.
And it really does have that deep blue color like the ocean.
That's because its atmosphere is rich in methane, which absorbs red light and reflects blue, giving it that striking appearance.
But don't let that serene blue color fool you. Neptune is a wild place with some of the fastest winds in the solar system.
We're talking supersonic winds, reaching speeds of over 2,000 kilometers per hour.
Wow, that's more than twice the speed of sound. What causes such extreme winds on Neptune?
Scientists believe it's partly due to Neptune's internal heat. Even though it's so far from the sun, it radiates more heat than it receives. That internal energy, combined with its fast rotation, creates incredibly powerful winds and storms.
And I remember hearing about a giant storm on Neptune, the Great Dark Spot.
Yes, it was a massive storm system, similar in size to Jupiter's Great Red Spot, but much shorter-lived. When Voyager 2 flew by Neptune in 1989, it saw this giant dark spot. But when the Hubble Space Telescope observed Neptune a few years later, it was gone.
So these storms can pop up and disappear relatively quickly.
It seems so. It just goes to show how dynamic and ever-changing these gas giants can be.
It's a reminder that we're getting just a snapshot in time with these missions.
Absolutely. The planets are constantly evolving and changing.
Okay, well, before we leave Neptune behind, we have to talk about its largest moon, Triton.
Triton, a true oddball in our solar system. Unlike most large moons, it orbits Neptune in the opposite direction of the planet's rotation.
You mean a retrograde orbit?
Exactly. And that suggests that Triton might have been captured by Neptune's gravity rather than forming alongside it.
So it's like a cosmic interloper drawn in by Neptune's pull.
That's a great way to put it. And it gets even weirder. Triton has Cryovolcanoes. Volcanoes that erupt with icy materials like nitrogen instead of molten rock.
Cryovolcanoes.
Yeah.
That sounds like something out of a science fiction movie.
It does, doesn't it?
Mhm.
But it's real. Triton is a fascinating world, and we still have so much to learn about it.
Well, this deep dive has been incredible. We've journeyed from the scorching surface of the sun to the icy depths of the outer solar system, exploring planets, moons, rings, and even a few mysteries along the way.
It's amazing to think about the sheer scale and diversity of our solar system.
It really is. And it makes you wonder what other secrets are out there, waiting to be discovered.
Who knows what the future holds? With new missions being planned and new technologies being developed, the possibilities are endless.
Well, on that note, we'll wrap up this part of our deep dive. We've covered a lot of ground, but there's still so much more to explore in our solar system.
Absolutely. And it's not just the tilt. Uranus has these faint rings too much dimmer than Saturn's.
Yeah, I remember those pictures from Voyager 2 back in the 80s. They were kind of eerie, almost ghostly.
Definitely more subtle than Saturn's bling. But Voyager also found a whole bunch of new moons around Uranus, adding to the planet's kind of mysterious entourage.
Voyager was such a game changer. It's wild to think those spacecraft are still out there, sending back data from interstellar space.
Talk about a long-distance call. It really shows how far we've come in terms of space exploration.
Okay, well, from the topsy-turvy world of Uranus, we arrive at our final gas giant, Neptune.
Named after the Roman god of the sea, which is fitting, given its deep blue color.
I always pictured Neptune as this serene, almost tranquil world, but I know that's not the whole story.
Right. It might look peaceful from afar, but Neptune has some of the fiercest winds in the entire solar system.
How fierce are we talking?
We're talking wind speeds that can reach over 2,000 kilometers per hour.
That's more than twice the speed of sound. I wouldn't want to be caught in a Neptunian hurricane.
You and me both. Those winds are driven by Neptune's internal heat. Even though it's so far from the sun, it actually radiates more heat than it receives.
So it's like Neptune has its own internal furnace.
Pretty much. And that internal energy, combined with its fast rotation, creates incredibly powerful winds and storms.
And speaking of storms, I remember reading about the Great Dark Spot on Neptune.
Ah, yes. The Great Dark Spot. It was a massive storm system, kind of like Jupiter's Great Red Spot, but it was much shorter-lived.
So it's gone now.
Yep. When Voyager 2 flew by Neptune in 1989, it saw this huge dark spot. But when the Hubble Space Telescope looked at Neptune a few years later, it had vanished.
So these storms can appear and disappear over relatively short periods.
Apparently so. It just shows how dynamic and ever-changing these gas giants can be.
It makes you wonder what other secrets are swirling around beneath those clouds.
Plenty, I'm sure. Every time we get a closer look at these planets, we're reminded of how much we still don't know.
Okay, well, before we leave Neptune behind, we have to talk about its largest moon, Triton.
Triton is truly unique. Unlike most large moons in our solar system, it orbits Neptune in the opposite direction of the planet's rotation.
So it's like it's going against the flow.
Exactly. It's called a retrograde orbit, and it suggests that Triton might have been captured by Neptune's gravity billions of years ago, rather than forming alongside it.
So it's like a cosmic refugee finding a new home around Neptune.
That's a great way to think about it. And to make things even more interesting, Triton has these cryovolcanoes, volcanoes that erupt with icy materials like nitrogen instead of molten rock.
Cryovolcanoes?
Yeah.
Seriously, it sounds like something out of a science fiction novel.
I know, right? But it's real. Triton is a fascinating world, and we still have so much to learn about it.
Okay, so we've talked about planets and moons, but what about those other objects out there, the dwarf planets? I mean, Pluto's demotion back in 2006 caused quite a stir.
Yeah, a lot of people were upset about Pluto losing its planet status.
Me included. But I guess science is all about updating our understanding as we learn more.
Exactly. And the reclassification of Pluto was really about recognizing that there are other objects out there in the Kuiper Belt, the region beyond Neptune, that are similar in size and composition to Pluto.
So Pluto's not alone out there in the cold, dark depths of the solar system.
Not at all. In fact, it has a lot of company. And thanks to the New Horizons mission, we got our first close-up look at Pluto in 2015, and it turned out to be much more interesting than anyone expected.
Those images were incredible. I remember seeing those heart-shaped nitrogen glaciers and those towering mountains made of water ice.
It was amazing. New Horizons showed us that even in the coldest, most distant reaches of our solar system, there can be a surprising amount of activity and complexity.
So Pluto might not be a planet anymore, but it's still a fascinating world in its own right.
Absolutely. And it's a reminder that there's still so much out there to explore and discover in our solar system and beyond.
Well said. It's incredible to think about all the amazing things we've seen on this deep dive.
Seriously, from the sun's blazing surface all the way out to Neptune and its icy moon Triton.
And we can't forget about those incredible rings around Saturn. They're not just beautiful, they're like a window into the past.
You got it. They're basically leftovers from the early solar system, like a giant cosmic recycling bin.
So by studying them, we can learn about how planets formed billions of years ago.
Exactly. Those icy particles are like time capsules holding clues about the solar system's earliest days.
That's mind-blowing. It's like the universe is telling us its own story.
In a way, it is. And speaking of stories, Pluto's demotion to a dwarf planet back in 2006 was a big one.
I remember that. It felt like a family member was being kicked out.
I know, right? But it was more about scientists refining their definitions as they discovered more objects out there in the Kuiper Belt.
So Pluto's not a lone wolf anymore. It's got a whole crew of dwarf planets hanging out with it.
That's right. And thanks to the New Horizons mission, we've seen Pluto up close and personal, and it's way more interesting than anyone imagined.
Those images were stunning. Mountains, glaciers, a hazy atmosphere.
Totally blew our minds. It showed us that even in the coldest, most distant parts of our solar system, there can be incredible geological activity.
It's like Pluto was saying, hey, don't underestimate me. So what else is lurking out there in the Kuiper Belt? Are there other dwarf planets we should keep an eye on?
Definitely. Eris is a big one, actually even more massive than Pluto, but a bit smaller in diameter.
Wow, another heavyweight contender.
And then there's Makemake, with its reddish hue that might be caused by organic molecules.
Organic molecules. Now that's interesting.
Right. It raises all sorts of questions about the building blocks of life in the outer solar system.
It feels like we've only scratched the surface of what the Kuiper Belt has to offer.
Oh, absolutely. It's like a vast treasure chest full of clues about the solar system's formation.
Okay, so we've covered a lot of ground in this dump dive. But as we wrap things up, I can't help but wonder what's next. What lies beyond the Kuiper Belt?
Well, beyond the Kuiper Belt is the realm of interstellar space, the vast expanse between the stars.
It's hard to even imagine what's out there.
It's a region of cosmic rays, dust clouds, and the faint light of distant stars. It's incredibly difficult to study, but we're starting to learn more thanks to missions like Voyager 1 and 2.
Voyager 1 and 2, those are the spacecraft that were launched back in the 70s, right?
That's right. They're still out there, traveling farther and farther from Earth, sending back data from beyond the solar system.
It's amazing to think those little spacecraft are still going strong after all these years.
It's a testament to human ingenuity and our insatiable curiosity about the universe.
Well said. And to our listeners, thank you for joining us on this incredible journey through our cosmic neighborhood.
We hope you've enjoyed the ride.
Keep looking up, keep asking questions, and keep exploring. The universe is full of wonders waiting to be discovered. Until next time, keep exploring.